Hello friends, today's question. A simple pendulum has time period t1. The point of suspension is now moved upward according to relation y is equal to kt square, where k is 1 meter per second square, where y is the vertical displacement. The time period now becomes t2. The ratio of t1 square and t2 square is. So we have a simple pendulum and initially its time period is t1. And then that pendulum is moved upward with the relation y, where y is a displacement, and then the time period changes to t2. So we have to find out what will be the t2 ratio of t1 and t2 square. So in this case, we already know that the time period of a simple, not SHM, but simple pendulum is t1, which is given as 2 pi square root of L upon G, where L is the length and G is the acceleration due to gravity. Acceleration due to gravity. So whenever the pendulum is in motion, or like in this case also, this G can be treated as G effective. Okay? So this can be treated as G effective. So when the pendulum is, you can say, without acceleration, then the G effective will be equal to G, and when it is acceleration given by the relationship y, because y is the displacement, from that we are going to find out acceleration, and then this G effective will be a combination of G plus the acceleration produced by the upward motion of the pendulum. So this basically G is our G effective. So let us call this a G effective. And G effective, you can say that G effective will be equal to G if for without acceleration. Without acceleration. So in the first case, the time period t1 now will be equal to 2 pi divided by L upon G. Okay, because now G effective is equal to G, that is without acceleration. Now for the second case, it says that the time period when there is a vertical acceleration present. So we say time period with vertical upward acceleration. Vertical upward acceleration. So in this case, the point of suspension is moving upward with an acceleration, whatever that acceleration is. So therefore, the effective acceleration changes due to gravity changes. You can say the point of suspension is moving with acceleration. Therefore, the effective acceleration due to gravity changes. Thus, the effective acceleration due to gravity changes. and we are going to find out this effective we can say acceleration, where in this case it will be the acceleration due to gravity because it is moving in upward direction. So the point of suspension is given is moving by the expression y is equal to kt square. Point of suspension is moving upward with vertical displacement relation is given as y is equal to kt square. So therefore the upward acceleration of point of suspension, upward acceleration of point of suspension, let us suppose is given as ay, which will be equal to double derivative of y with respect to time t, and this will be equal to 2k, and k is given as 1 meter per second square. Therefore we can say that ay is equal to 2 meter per second square, as k is equal to 1 meter per second square, which is given to us. So we found out that the upward acceleration for the point of suspension is 2 meter per second square. Therefore the effective acceleration acting on the pendulum, effective acceleration acting on the pendulum, which is equal to g effective, will be equal to g plus ay, and it means it will be g plus 2. So g effective will be equal to g plus 2, and g is supposed to be taken as 10, so this will be 10 plus 2 and will be equal to 12 meter per second square. So new time period, that is t2, the new time period which is given as t2 will be equal to 2 pi square root of L upon g effective, which becomes as 2 pi L upon 12. So we already have T1 is our 2 pi upon L upon g, and this will be equal to 2 pi L upon 10. So squaring and dividing as per the requirement, we are supposed to find out T1 square upon T2 square. So we get T1 square upon T2 square is equal to 2 pi square root of L upon 10 whole square divided by 2 pi square root of L upon 12 and whole square. So we can let it combine it. This becomes L upon 10 and this is 2 upon square root of L upon 12 whole square. So pi goes with pi, square root cancel with square root, and we are left with L upon 10 and L upon 12. So here L and L goes. This becomes as 12 upon 10, and we get this as, we can cancel it by 2. So this is 5 and this goes by 6. So we are left with our 6 upon 5. Therefore, the ratio T1 square upon T2 square is equal to 6 upon 5. So if we see the option available is A is the correct option. 6 upon 5, A is the correct option. You can say option A is correct. So this completes the question. Thank you.